Computers do two things: store state information and manipulate state information. One place to store state information is in the computer's registers. Now, registers are simple but fast storage devices that each store a set number of bits, where a bit is the smallest piece of information stored as a 1 or a 0. In this example, all of the registers store 8 bits. RTL code is a simple language that tells us how we want to transfer information from one register to another register. Most computers use a number of registers, but a computer may have as few as 1. For the sake of this example, though, we number the registers from 0 to 7. Perhaps the simplest RTL instruction is an instruction that transfers the contents of one register into another register. For example, this line of RTL code commands the computer to transfer the contents of register 5 into register 4. Notice that the arrow points to the register where data will be stored. The contents of each of these registers can be any number that can be encoded with 8 bits. In a more sophisticated computer, the number of bits in each register will likely be greater. In some computers, we can simply store a specific number into a register directly. For example, we could store the value 0 into register 0. Notice that an R followed by a number symbolizes when the contents of a specific register are being used. But a number without an R is simply the number. As a quick side note, the term transfer is a little misleading because we can transfer information back into the same register. For example, we could store the contents of R6 back into R6. But let's explore a more complicated example. This RTL expression shows that we want to add the contents of register 1 with the contents of register 2 and store the sum of this addition into register 3. If we removed this R, then we would simply add 1 to the contents of register 2 and store that sum into register 3. Now, there are a variety of RTL instructions, but the basic operations consist of arithmetic operations, logic operations, and shift operations. These operations are performed by a component